Okay, we're looking at the exam style practice paper from the first year textbook, and we are on question 12. Sort that out. Okay, that's better, right? So we're looking at question 12. So we've got 9 to the power of 2x equals 27 to the power of x squared minus 5. Now, if you spot that 9 and 27 are both powers of 3, this question becomes relatively straightforward. You can do it taking logs, but that is making it a little bit more complicated than it needs to be. Okay, so, because if I can rewrite 9 as 3 squared and 27 as 3 cubed, yeah, so that's sort of the key thing to spot. Then I can just say, well, if I want to get rid of those brackets, I'm going to multiply the powers together. So that will become 3 to the power of 4x on the left-hand side, and that will become, so let's get me see, right, that will become 3 to the power of 3x squared minus 15. So that whole x squared minus 5 is getting multiplied by 3. And then if I know that 3 to the power of 4x equals 3 to the power of 3x squared minus 15, then those powers must, or I don't know why it's turned into a line, but those powers must equal each other. Okay, so then becomes a quadratic to solve. So I'm going to bring the 4x over to the right-hand side. Let's bring this up a little bit so you can see the whole screen. You could then pop that into a calculator to get the two roots. I think it's going to factorize. So if I do 3 times 3, I get 9, and 5, so that would give me the 4. So if I do minus 9x plus 5x, get x is minus 5/3, or x is 3. And if we go back to the question, it did say values, so I'm happy I've got 2 answers. There's no reason why, x can't be negative or x can't be a fraction. And of course, what you could do, now we've got those, our two answers here, you could just substitute both of them back in and just double check that when you substitute minus 5/3 in, those two do both give you the same solution.